All right, good evening. Tonight's webinar is about controller configuration and setup and product selection. We're joined tonight with Titan, our warehouse dog, who sits here and listens to quoting all day long and should at this point be able to quote you in order, but I don't know why he doesn't. He says, thanks, but I'm going back to bed. All right, I had a poll up here and thoughts, interesting results here. It was, what is the most complicated thing about doing display when you first got started? And number one on the list was sequencing the songs. On sequencing, and we'll of course have that in a later session here at the last, second to last in session 7. On sequencing, you have two options. Of course, you can do that yourself, and that is definitely a skill. It's sort of like singing or playing a musical instrument. Some people just got a magic touch and some people don't, and they make it work. The best way to do that is with pre-made sequences from the different vendors, and there's a way to import those types of things. Second most common reason is configuring the controller receiver. We get that. We know that a lot of people have confusion with that. We will post some links. We are in the process. We're 1/3 of the way through. I'm sorry, 2/3 of the way through of reposting all of and redoing all of our videos for setup. So we've already redone all of our long-range receiver videos for every conceivable configuration, and then also the AlphaPix. And we're in the process of remaking all the HinksPix videos. So that's every little nuance and piece of setup. And then last was looks like finding the right information. I will give you that people come to us and they are overwhelmed. There's just so much information. As I've said before, don't get overwhelmed with that information. Sometimes you just got to get started. You'll never be as good as somebody who's been doing it for 5 years, and nor do you need to be that good. Just get started. Okay, speaking of get started, let's go ahead and start our session here. And I'm still the same guy as the first session and all the others, found at Holiday Coro. The Flex system that we use at Holiday Coro was developed by me. Holiday Coro is one of the first major vendors selling a lot of very sophisticated pixel controllers, going back to 2009, 2010, 2011. And out of that came the AlphaPix and then the Flex modular system, and then a joint partnership with Joe Hinkle, which is the HinksPix controller you know today. And that has served us very well. This is just kind of nuggets of knowledge. I've worked with a lot of different types of projects over the years, and then sometimes it's just obvious where the next thing comes from. So if you've got a network switch in your controller, that came from Holiday Coro. We were the first to implement those because we needed a daisy chain controllers at the Ethernet level. We had the first push to connect connectors, and I know you think polyfuses came after because it seems like we've added them recently. We actually had polyfuses at the very beginning. People said, well, this makes no sense. I want blade fuses, and we took them off, and then now we brought them back. So I guess bell bottoms and polyfuses all come back eventually. So we've come out with a lot of different innovations over the year. Current sensing was on our controllers early on with the xLights controller, which is a controller even most people don't even remember. So lots of innovations over the years that we've worked on, and we're happy to have helped move the market forward. Many of these things, they're not patented, so this helps you get a better product because everybody just copies everybody and makes a better product and comes up with a better mousetrap. All right, so let's go ahead and get started here. As I've mentioned before, controller selection is obvious. It's obvious once you know what we're building. And of course, this is all led up to this point, which is you got to have your design. So a little trivia here. So back in the day, if you're an LOR person, you go back to the early 2000s, you had really pretty much one choice: buy a 16 output AC controller, and that was what you did. You either had 1, 2, 3, 4, 5, and that was just how big. And your display was defined as how many channels it had. It was 128. Oh wow, you had 256. So that was easy. I really kind of wish it was like that. Even when Pixel controllers first came out, there were 16 outputs, and then we just basically sold all that. There is a lot of stuff out there, not only from different vendors. While the technologies are generally the same, like long range kind of exists, expansion exists in different product ranges, it's done differently with some pros and cons of different vendors. But that complexity exists for a reason, and it's mainly around the ability to lower cost and have more flexibility than the old school 16 outputs. Okay, so again, as I mentioned, display design is just super easy. It should be obvious. If you were building a house and you've designed the house, the engineer doesn't really have to do a lot of guessing. when they need to know what lumber to use on that floor, they know how many pounds of weight we have, dead load and live load on the floor above, and we just simply go to a table and say, this is the beam we need to use. It's pretty obvious. And that same thing exists within controller selection. Now, ambiguity does exist when you're talking about future expansions. It's not uncommon for customers to bring us a project and they want to do this year, but they want expansions for the future. And sometimes when there's not complete clarity, like I want a tree over here next year, or I want a matrix here next year, those can then sometimes create confusion. But even then, long range technology allows you to kind of just work around a lot of those types of things. Okay. So physics. So all the controller vendors all deal with the exact same thing. We have to deal with reality and physics. And when we talk about electrical signals, they don't change between vendors. Pixels are generally pixels. There are some esoteric or other unique things, but I am going to talk about things that exist in the mainstream of the pixel world. So first of all, you have to look at where we came from, which was AC lights. Remember, we had 120 volts, and you can have these long extension cords, long runs of light. You want to put 300 lights on an individual output? Hey, go right ahead. 500? Oh yeah, they're LEDs. Great, no problem at all. It was all easy. In fact, unless you had incandescent lights back in the day, especially once the LED lights came around, it just didn't even matter. You didn't even need to really know what you were doing. You just like throw stuff on a controller output and move on. With pixels, it is a little bit more. It's okay. It's a lot more complicated. So we need to make allowances for all those unique things. And we'll talk about those two major areas. And we're working with 12 volts here. And there's some good reasons why it's 12 volts, as we'll say, talk about here in a second. So there are essentially two limits that drive everything that we decide on pixels. It's power for the pixels and the data for the pixels. In your wire, you have a pigtail, and it has, I don't know if you can see this, it has 3 wires, right? So Holiday Core invented the X-Connect. We didn't name it, we call it something else, but we came up with the plug and then the wiring standard. And we came up with, of course, color standard, well, black being negative in the US and then positive being positive. And that positive wire provides the power for the chip itself and the LED. Now, we also have a data wire. Now, there are 4-wire pixels, and early on in pixels, that wasn't uncommon. There was a clock line, and I think everybody realized 1 extra wire for what we were getting out of it wasn't worth it, and so we all really pretty much standardized on 3-wire pixels. And so there's really not too many 4-wire pixels anymore, like 6803, like light-o-rama used to have. So we have to consider those. Now, how we share those is that ground wire is shared between the 2 positive wires. So on that red wire, you might be running 12 volts, but on that data wire, we're probably running 3.3 volts. So this is what defines these limits. So it's important to understand that while you may be sitting 12 volts down that wire, at the pixel, it's totally different. So you can see that we have about 1.7 to 2 volts at the actual LED. Now, they're current limited and some other things, and the chip does some of this manipulation of the voltage and the current limiting. But we have to get that voltage from 12 volts down to, let's say, 7 volts. I mean, I'm sorry, 1.7 volts or 2 volts to get it to the specific color, red, green, or blue. Now, the chip itself typically will run at 5 volts. So whenever you look inside of a pixel, you'll often see, like if you look at a 5-volt pixel versus a 12-volt pixel, the 5-volt pixel, it's got less chips in it because that's not dropping the voltage down. It's already running at 5 volts, and then the chip itself is reducing the voltage down to the actual voltage and current necessary for the LED. So what's also happening is on that yellow wire is the data line, and that's usually 3.3 volts. That's very low. Now, on a circuit board, no big deal. That's perfectly normal. On your CPU, you'll see that it has like 3.3 volts. You'll see that number all the time, and that's normal. But on a CPU, you only have to go inches. On a controller system, we're going feet. So that means we're going to have some issues there. So that's why you see 5 volt, 12 volt, and 24 volt. 5 volt is, you'll actually see them usually cheaper because we don't have the dropping resistors in them, and they're running natively at the voltage that the chip can usually drive. So there's just less stuff in the chip, and that's why those pixels are typically cheaper. They have some disadvantage. We can't go as far, right? Then we have 12, and this is kind of probably the sweet spot. It's not too far above 5 volts, like 24, 36 volts, or 48 volts. But it's enough voltage that allows us to get pixels far enough down the line. And that's why, like if you have a prop, we don't typically need to go 1,000 pixels or 500 feet or something like that, right? So that's why you'll typically see 12 volts used. I will say that 12 is being the most common voltage you'll see on pixels. Okay, so hopefully we understand that we are not actually running pixels at 12 volts. We're actually running pixels at 5 volts, which then gets reduced down, bucked down to about 1.7 or 2 volts. So that's why you don't see these 24 volt pixels typically. Okay, now imagine that you have a 12 volt signal. So imagine you got one person that's a 12 volt signal and another person that's another 3.3 volt. And we're standing at the end of an end zone in a football field, and we are yelling across the field. The 12 volt signal has a bullhorn, and the other person at the other end has no problem hearing the person that's yelling through the bullhorn that is the 12 volt pixel. Obviously, I'm using an analogy here. And that 3.3 volt has no megaphone. What is the chance that you're going to clearly and accurately hear at the other end of that football end zone 3.3 volts, which is the person just yelling, over the 12 volt with the guy that has the megaphone? That's what the low voltage of that signal essentially is. It just can only go so far. And because it's a lower volume or lower voltage, that means it's more prone to corruption. So if a car's driving by that football field, it may cause it to be unhearable. But maybe if it's perfectly clear outside and there's no other cars or people talking or there's not music, great, you can probably hear it maybe. But then anything else, which is the noise, will interrupt that. So that's where you get issues with the distance. And this is why the number varies. So we use 25 foot as our absolute guaranteed going to work number. So from the start of the output of the controller to the pixel at the first, 25 feet. Definitely going to work unless you have some really weird stuff. But you might be able to get 30 feet or 35 feet or 40 feet. Heck, for that matter, you might get 45 feet. Then your cable quality becomes a big critical factor. How good is the quality of the cable? Did you have a high voltage power cable running next to the data cable, and that's causing some interference? So there can be a lot of factors that come into the data signal being corrupted. So essentially, once you go past 25 feet, if you really want it to work, guaranteed, you really need long range. We'll talk about some exceptions because I know some of y'all are out there yelling, no pixels. All right, so how pixels work are a game of telephone. What happens is that when you go from the controller to the first pixel, that's your first jump. Great. You have a certain distance you can go, 25 feet. It hits that first pixel. That first pixel typically will repeat the signal. And there's some variations depending upon the quality of the chip and some other factors. But that chip then says, oh, here's my data. I'm going to hear that, and I'm going to slice off my little part of the data, and I'm going to pass it on down the line to the next pixel. So every pixel actually thinks it's the first pixel. It has no idea that it's not the first pixel. Its job is to just say, take my first piece of data, pull it off, repeat it down. So when it repeats it, it's increasing the voltage back again to usually the 3.3 volts. And that means the next chip will then be able to hear it. So theoretically, you should be able to go 25 to the first pixel, 25 to the next pixel, 25 to the next pixel. Now, you do eventually run out of power for just the pixels to run at that power wire. All right. Now, again, if you have any questions here, click that. If you're on your phone, click the Q&A button at the bottom. Feel free to post your questions. Okay, so terminology, controller. This is usually the brain. It's usually referenced as being the most smart part of the system. Typically, in a residential display, you'll have one controller. Now, you may have bought over time multiple controllers. You might have bought, it's decided, okay, well, was it best to use a receiver here? I have this huge matrix, this big, massive mega tree. Sometimes it's just better and cheaper to get a controller. But a controller has a lot of sophistication. It can put out a lot of data. But it has also all of the other complexities that come with a controller, which is all the expensive chips like networking chips. Our HinksPix Pro has 3 CPU total chips on it, not including all the other stuff for memory and display and Ethernet. So that's why a controller is just more money. You may also have things like audio on our HinksPix and that type of thing. So that just results in the higher cost of a controller. But when combined with long range, that then can be cheaper. So long range, again, 25 feet, does 2 things. One, it doesn't use 3.3 volts to send your data signal. It takes that signal, which ironically is at 3.3 at the controller, and then it then boosts it up, gets it to usually 12 volts or differential 6 volts, 12 volts, let's say for simplicity, sends it down a Cat5 cable, which is usually much better quality than even your Pixel cable because it's all twisted and it's high quality usually. And then at the other end, pulls that data out and then puts it back onto the wire and then out to your pixels at the 3.3 volts. That also is then being combined with new power. So this gets over the issue of running distances for power because you do run out of power, not only for the data signal, but eventually even the pixels run out of power. That's why you got a string of some odd number of pixels. You just run out of power eventually, right? Now, what's in the receiver is really pretty much just a power, like power supply, some cable outputs, and then some basic chips to decode the data and some fuses. That's pretty much what it is. So that means you have lower cost. So a receiver could be 40, 50, 60% lower cost than a controller of equivalent number of outputs. Now, this also allows you to do some unique things. This is where the flexibility of long range comes in. It allows you to split the signal or repeat it in a daisy chaining. Now, most systems, so if you look in the bottom right corner, what you should see, let me see if I got my pointer going on here and make it visible. All right. So in the bottom right corner, this is a Falcon receiver. You'll notice it has a red connector, another Holiday Coro innovation of making them different colors so that you're aware that they are long range, not an Ethernet, because it does use the same cable. It is not Ethernet, which is being sent here. So we have a Falcon here. It has an in and an out, right? Now, the Falcon is different. It doesn't do splitting or Ying, like where you can split the signal off into multiple different directions. It's simply just daisy chaining. The Falcon also is not a repeating product. So in other words, when the signal comes into the long-range receiver, it is not being boosted back up just like the signal is on a Pixel and then resent out. It's just coming in and going out. It's just the wires are tied together. And that explains why if you look at these two boards, you'll see a vast difference in the number of chips, even though they both have 4 outputs and 4 fuses. The right upper corner is a 4-output long-range smart receiver. Now it has 3 jacks. The lower left one's the input. Then there is a output that splits in Ys. So that means that you could have a cable coming in, and let's say you got to go from the middle of your display over to the right side of your display, and then you want to go down to the front right side of your display. You could then split that off, or you could then go to the front and the back of the right side of your display. And if you're doing a massive display like we do displays in theme parks and drive-through parks or zoos or malls where we have hundreds and hundreds and hundreds of feet of distance between all of the different lights, that is an advantage. So this is the value they get with long range, is the ability to do these things, especially with the daisy chaining, but also in our case, the Ying or splitting of the signal. Okay, SPI, you're gonna hear this all the time. This is probably an annoying term, but serial peripheral interface. Most of the time when we're talking about that we're referring to, hey, this is your cable right here, and we're putting data out on this cable. That's where the SPI, which is the data, the yellow wire at the end, is coming out. And it's almost always referred to as kind of the whole thing. SPI output with being the power and the data signal. An output could be loosely used for anything. It could just refer to the output cable, right? So this controller has 16 outputs or 32 outputs. And this could also apply to AC receivers. So I have one over here, but if you have an AC box, like an old LOR box or our AC controller, that would also be referred to an output. So usually that's the point at which something is connecting to some sort of light. You'll hear the word port used all over the place. I mean, it's just littered everywhere. Ports this, ports that. It generally just means that there's a stream of data coming out of something. And ironically, sometimes the port is even referenced in connection with being an SPI or an output. A port can also be a stream which you go out one receiver into another, out to another, into another, and so on. So it does have a variety of different terms. Okay, so I keep harping on these rules again, over and over and over again. 25 feet between the first pixel and the controller or receiver. If you need longer distances, use a receiver. We're going to talk about the other exceptions down here. If you want a very, very generic explanation on how many pixels can I connect to my controller or receiver, no more than 212 millimeter pixels at 50% output. 50% output, as we've talked about before, pretty normal at 12 volts. It's not uncommon for people to run them at 20. Heck, I've seen people run them at 30. I'm sorry, common to run them at 30, but even people running them at 20% output. We support our seed pixels. This, again, will all vary. 250 seed pixels at 50% 12 volt output. And when we say those numbers, we're saying 50% reduced because you can go into xLights and change the output percentage. And that just caps the amount of power that any given pixel can consume. That is assumed to be all the pixels, all on, all white. Because if you're just doing red, you're only using at best a third of the power, right? So you're probably not having a raw problem with power at that point. So you're always looking for the worst case scenario, all on, all white at the same time. Now, if you generally are talking about a 12 volt pixel, so you go to the end of the pixel and you use your pixel tester. So at the end of a pixel will be a female like this with a pins. Put your pixel in there. The two bottom ones next to the flat end is the positive and negative. If you put a multimeter in there and you measure something below 12 volts with the lights on at full white and it's below 9 volts, you're going to get some weird stuff. The chips just don't operate. I know they run at 6 volts, right? Or 5 volts. Why 9 volts? Because there's some dropping pieces in there, and some chips will work better at that. Some chips will work okay at that. Some will go bonkers at 9 volts or below. So it all just varies. All right, so my experienced people are going to go, hey, but you didn't talk about power injection. Well, not only do we know about power injection, in fact, this was very common before long range was instituted. That was the solution. You had to do a house outline, you were doing a bunch of power injection. Power injection, this is the story I always use, it's Q-tips. Q-tips on the box never say put these in your ear, because some people put them in their ear and then stick them through their ear, and then, of course, the Q-tip people don't want to be sued. They're perfectly fine to use in your ear if you know what you're doing. If you don't know what you're doing and you're walking around and talking to your cat while you're putting your stuff in your ear and you get distracted, yeah, that's going to be a problem. And for us, our insurance company, due to an incident, indicated, yeah, you can't tell customers how to do power injection. GM won't tell you to throw a turbo on their Corvette they just sold you. Good luck for you, right? So power injection is a perfectly valid solution. You will know if you have the skill to do it or not. If you don't know what you're doing, please don't do it, because it has resulted in fires. And if you do it, always use the appropriate hardware. We even sell products for fused power injections. This product over here on the right is one of our fused output boards that goes on a power supply. And we also sell another one for fused outputs on long ranges. So yes, absolutely, you can do it. We even sell cables for power injection. You can modify them and stuff like that. Power injection is very complex, makes your troubleshooting harder, and people blow a lot of stuff up with power injection every year. It's never changed. It's always the same. So only use it if you know what you're doing. So reduced output, yes, as I just mentioned, you can run more pixels on a particular output if you reduce the percentage of output. If you don't know what the number is, and most vendors, ironically, don't even list the number, just test it. Hook up all your pixels. It's either going to blow the fuse or it will cause your lights to not look correct. So if you look at your first pixel and your 358th pixel, they're probably not going to be the same color. And again, you need to test it white only. So if you're doing any point where you need white as a color, make sure you just turn all the pixels on. And then you'll know. You could tweak it, right? So here's a question. Can you increase the power supply from 360? Actually, they're normally 350 to 600 watts. Will this give you more power? Yes, you'll have more power, but it won't matter, because what matters is not the power at the start of the string, how much power could be delivered. It's how much power is at the end of the string. If you want an analogy, you probably live in a neighborhood, they have a water system, and they have pumps that are the size of small cars pumping water to your house. But that doesn't mean that you can pump 9 inches of pipe of water through your faucet, because that power supply might be capable of delivering lots of power, 600 watts, but by the time it gets to the end of the pixel at the very end, because that's what matters, is how much power can you get down the wire, that's not what's going to be there. It's the same thing, again, if you use like water hoses. Anybody's ever put like a 100-foot water hose on another 100-foot water hose, and then goes another 100-foot? The water barely comes out at the end. But the power of the pressure at the very front of the faucet is exactly the same. It's the losses in the wire. And so the only way to overcome that is bigger wire. And then, of course, you get this whole loss of return on investment. We could make big, thick wires, and, that would just not be worth it. And here's a little trivia nugget. Anytime you see people saying that they're 18 AWG on their pixels, it's absolutely BS. There are almost no pixels any vendor sells that have 18 AWG. In fact, the Chinese are fully aware of this. They know that they print 18 AWG on wires. We've dealt with vendors who print it on there. So be aware, all that's BS. So if you're using like 18 AWG because your vendor says it, or it's even printed on your wires, yeah, I don't believe that. Take out your calipers, measure each wire, and then calculate the total number of wires and look online, and you'll find out that that's not true. Now, data. Hey, I'm doing a house outline, but I got to go 50 feet. I know I can use one of these null pixels. So over here on the right, you'll see that we sell this repeater or null pixel. Basically, you just throw it in the line. So, you put your 20-foot cable from the controller, throw one of these in there, go another 20 feet to the next thing. And what that does is that's basically a pixel. And as I mentioned before, a null pixel repeats the data, right? Okay. So it does not fix magic power drops, because you still have to get power through the wire on that red wire to power the pixels. So it may repeat the data. And again, it doesn't fix bad quality cables and problems like high voltage and stuff. Okay. Now I'm running a little behind again, as usual. Now, just FYI, we're about to launch into xLights for demos. If you don't use xLights, that's okay. You will need to do a little more work if you're using like light-o-rama or some sort of application that's third party. If you happen to be watching this and you're using like a console, or you have a church or a theater, you will need to use the design tool in the HinksPix Pro. You can see an arrow up here in the right that shows where you do that. And that just helps you configure all the outputs. xLights is multiple times better than this process, but this is just the process that's required because of interfacing with legacy devices with DMX universes. The AlphaPix also uses it, but it's very simplified. You can see, you just simply say output 1, universe something, channel, whatever, however many pixels, and you're good to go. We have videos on how to configure all these things. Again, we'll have a link at the end of the video. Okay, now it's time to pick the controller, what we've been waiting for. So step 1, what we're going to do is select the controllers and receivers. So let's go ahead and pull up my xLights, and I've got my demo here, and I've got just kind of a simple display. It's on a very wide house over a large area, and so this will make for a somewhat complex display. Now, if you've got a front yard that is 40 feet wide and 15 feet deep, you're probably going to just do one controller. Just get a controller, get however many outputs, 16, 32, whatever, and call it a day. You're going to be fine because you can get those extension cables all out there, right? Put a controller in the middle of a 40-foot wide yard, you get a 20-foot cable over this, 20-foot cable over there, and you're good to go. Now, if you're in this house right here, that is not happening. We are definitely past 20 feet. So you got something like this, you're going to need receivers, almost surely. Or will we? I don't know. So what we've got here is got some candy canes over here. We've got 6 of those. We got a copycat here. We got some house outline up on the house, and that's kind of far away. And then we've got over on the right 6 more candy canes, some arches at the front, and a copycat that's bigger up here, and a singing face. So when I look at this, the first thing I'm trying to do is, what are the major areas and distances here? I can just tell you that we're probably not going to be running a bunch of cables across the driveway. So I'm also considering that, because even if this driveway, let's say I could put a controller over here on the side and then run the cables across the driveway, probably not an ideal way to do that. A data cable with a power going across every single one with your car driving over it, just a recipe for disaster. It's just better to put a receiver over there directly in most cases. Now, you may have cracks in the driveway and you run them through the cracks or whatever. Maybe that works for you. But generally speaking, I'm going to isolate that. And when I look at this, I see 4 distinct zones: left driveway, right driveway, front center, and the entire house as a whole. Now, if I was looking at this, my first question would be to a customer, hey, are you planning to make that house outline permanent? Because if it needs to be permanent, we need to put the controller at the house, because that's going to be the brain. A receiver, during Christmas, you put these props out there during Christmas, you just put them up, you take them down, they're not up year round. It doesn't matter. And the receiver doesn't have any brains. It's not going to be able to play the SD card playback or anything like that. It needs a controller to operate the receiver, because the receiver gets all its data, hence the name receive, from the controller. So I would be saying, hey, are you going to be doing this house outline as a permanent full year-round thing? If so, we're putting that controller up here and everything else is long range. Now, if this is not up on the house and it isn't permanent, I would then start saying, hey, where are my most dense, most number of outputs? So the next thing we need to look at is how many outputs we need. Now, how do we know how many outputs? We know which prop and how many pixels. So I'll tell you some of the dilemmas. So let's start looking at the left side over here. The first thing I see is got a candy canes and this little copycat right here. And these are all going to be run together. Now, if I was designing this, I might say, hey, if I was going to do 6 candy canes, like over here on the right, this is not by accident. Don't do 6 candy canes. Do 8 candy canes. Do 4 candy canes. Do 16 candy canes. The receivers and controllers typically almost always come in 4, 8, 16. So when you build something, even a mega tree, don't build 24 string mega trees, build 32. You already paid for the whole box. Why not just use extra outputs, right? So if you were doing 6 candy canes, just do 8 candy canes. I mean, because again, you've already got your money sunk into the controller or receiver. So first thing I would do is look at that. Of course, you would consider that in the design phase. But here I have 6 candy canes. They each have 99 pixels. So that clearly is below 200. So I could daisy chain them. And then I also have this copycat, which has some number of pixels. Let's see here. It has 195 nodes on it. So that needs that needs a dedicated output. So looking at this, I would then consider for the customer, do we want to run these in daisy chain? Because we could put a daisy chain for these 2 candy canes together. So we could run a cable to one, then off of this one and go to the next one. Usually what I'm going to be considering is how complicated is that for the customer to do, and how hard is it to set up and troubleshoot. Here you would have to run the output of the first candy cane down to the second one. It also means you can't swap out the candy cane. So if one candy cane is dead, usually it's specific to that kind of thing because you have a daisy chain coming off of it going to the next one. So now you need to be very specific as to the location of that candy cane. So for simplicity in this design, I'm going to say 1 output to each individual candy cane. Efficient? No, not necessarily. You got 100 pixels. We can easily run 200 at 50%, no problem at all. But it's going to be easier to set up. It also means I'm going to need slightly longer distances on the control box. So looking at this, I have 6 candy canes, so I definitely need 6 outputs. Now that I've decided I'm going to put 1 output on every single candy cane, and then I need one dedicated output from my copycat up here. So we have 7. So great, we have a receiver. It's available in 8. We'll get an 8 output receiver, or 2 4 outputs technically, actually, because that's how xLights is just built around everything being force. Okay, so one receiver box on this side of the house. Now, over here, same deal. I've decided we're just going to do one output per candy cane, and we have 6. There's only 4 and 8. I'm going to get another 8. So now I know I need 2 8 output receivers. Okay, that's good. Coming up here, I have the house outline. I will need a receiver. It's just too far away from anything down here, and we're not going to be running this as a full-time installation, so it's not year-round permanent. So we'll reuse a receiver up here. It'll be inexpensive. Again, using my 25-foot roll, I'm probably going to look at this. I'm going to think, hey, where's the best place to put this? Maybe I decide like down here in the bottom left corner. I can then go over here, hit this left side, come up, go over here, go down, run a cable up to the top, and then down again. I'll say, yeah, just one output. So one receiver. So I'll have one output here on this left. Then I'll have another output for this one. This is 2 on these. Or maybe not. And then the third output I'll have here going down and around. And again, we'll just say I've done all the math. There's no more than 200 pixels, and these are 12-volt nodes. So we need 3 outputs. We'll need a 4-output receiver. All right, so that means that if we have 3 receivers around the outline of the display, we need then a controller somewhere. So we have these arches. They each have 150 pixels, so we really can't daisy chain them. So those are dedicated outputs. The singing face probably needs 2 outputs because it's 300 plus pixels. And then we have our copycat, which is 200. So this is 1 output. This is 2 outputs, 3, 4, 5, and 6. Now, we don't sell controllers that have 6 or 4. Well, actually, technically, we do sell 4-output controller, but not for relevant here. So we really go to a 16. The cost difference between, and sometimes people go, well, why don't you sell an 8-output controller? Because the actual cost of a difference between a 8 and a 16 board is almost irrelevant. Actually, there's more cost in just the pigtails and the labor to hook up the pigtails than it is the actual entire board and the contents of all the connectors and chips. So anyway, so we're just going to use a 16 output. So we're going to use a 16 output local SPI connections for these items, not that one over there. And then we're going to use long range going over here, and then I'm going to daisy chain off of this left side. So I'll get my cable across the driveway up and then into the house. And then this one, I'll go over to the right. So we're going to daisy chain 2 of these receivers and then one over to the right. Okay. If you have any questions about what I just talked about, let me know. Okay. So next thing on our list here. Let's get our mouse back here. Here we go. Nope. There we go. xLights. Confirm the model wiring. So this is the point. Again, you should have the models mapped to the real world. We talked about this in the model meeting or webinar last Tuesday, and it has to be right. So let's just recap that. I know I sound like I'm harping on it, but this happens all the time with customers. So if we're doing this house outline, again, if I'm going to be putting a control box right here where my cursor is, I'm going to start at the blue line and go to the left. Well, you can see that this is starting at the blue square. That's good. All right. Well, this one, I'm going to go from here, the green square, to the blue square, and then I'm going to go from the blue square to the blue square to the green square. So what do I need? I need green square. That's good. All right. And then I come down here. I'm going to start at the blue square because I'm going to daisy chain this left to the right. That's good. All right. And then I check this one up here, green square, because I'm going to start right here at the green. And then I'm going to go over to this next one. It needs to be green square. Good. We got green square. And then finally, I'm going to finish with this last piece, green square. That matters because xLights in our next step is going to want to connect all these together. Okay. So the rest of these, you would, of course, like we've talked about before, when you're doing your arches, make sure that like here, if you don't know where the pixels are actually really going to be wired to in your model, make sure that you look at that. Remember, reverse side view. And in this particular case, we know on this prop, when looking from the back, we're starting at the right side. What's the blue square? That's not good. Why? Because I'm probably going to put the controller maybe next to this tree and then go over here to this blue square, then to this blue square, then to this green square, and then to this green square. So we got the green squares right, but we're starting in the middle on both of these for 2 and 3. So we need to do blue square. So this is where you need to make sure that we have everything perfectly aligned. xLights has no idea what you've built. It has to be told. Okay, so let's just now say we've got all of our props set up, and now we're ready to visualize, or actually set up the controller. So let's bring up our xLights again and start controlling. So I'm going to go to our controllers tab, which has nothing in it right now. And this is going to be a HinksPix Pro with long range smart. We do have something called long range regular, which is less sophisticated, works with the AlphaPix and the HinksPix. We do use that in certain cases. It is vastly simpler to set up. And in certain cases for customers, we like simpler setups for certain customers, and we will use long range regular. Okay, so I'm going to go over to the left side here, and I'm just going to go ahead and add my controller. So this all, as I said, always name your things correctly. Front, center, yard, HinksPix Pro. Okay, this is critical. You must select the vendor correctly. So if you've got an AlphaPix, you need to select Holiday Coro, then AlphaPix. And if you're using a long range or the current one, it'd be the Flex. The 16 and the 4 are the classics, so you don't use those usually. So we're going to select HinksPix, and then you have to select the right version. And why this matters is the version 1 and 2 have a pixel count of 680 outputs per port. And the HinksPix Pro version 3 has 1024 per port. So xLights knows how many pieces of data it can send. So in this particular design, we're going to go ahead and use a HinksPix Pro version 3 because that is a very friendly controller to long range since it gives us a lot of outputs. We're just going to take all the defaults, put in my controller address of 10.10.10.0. What? 107. Okay. So I'm going to go ahead and just save that over here on the left, and we're good to go. All right. At this point, you could go ahead and just click the open button and see if this will open up your your controller. That indicates the network's all set up. I have not talked about this as a setup for networking. Networking is a whole different thing. We have videos on how to get the controller hooked up to your PC. That's a different thing. Okay, so we're good. Now let's configure it. We're going to go down to the bottom left after we select the HinksPix Pro Visualize button, and a box will appear. So let me bring that in here. First of all, if you can't see everything, you can do this zoom function, make them smaller or bigger. So if it's hard to see, you'll want to do the zoom. Okay, now what you are looking at right here is the ports. Remember, I keep talking about these pixel ports. Now let's connect that to reality. So I'm going to bring my browser over here. Here's the actual controller. This controller from ports 1 through 16 has local SPI. Yeah, that's not good. We'll just pretend it has long range. This one is not appropriate for this thing. Pretend it has long range output right here. And let's pretend it has SPI down here on 33 through 48. All right, so what you're looking at here is you are looking at the 4 output cables. And let me actually go over here and just show you a real world representation. There's a reason why those little blocks on the left are color coded. See how they're red, green, blue, and yellow? So I'm going to show you a picture of a controller here. All right, so there we go. Oops. So here's the controller. So if we look closely at this controller, we're going to see 4 red jacks. So in our configuration, what we're going to have is we're going to have 1 through 16. So this is 1, 2, 3, 4 on the furthest left jack, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Why is that? It's because a Cat5 cable has 8 wires in it. Paired together, because we need 2 wires to send long-range data, we have 4 pairs of wires. And we have 4 ports, 1 port per pair of wires. That's why they're grouped together. So when xLights is showing you that little block around the red, that's telling you, hey, this is a block of outputs right here. All right, so that is the first port. All right, so what are we going to do? I am going to, remember, use 2 different outputs. I'm going to use 1 to the right side and 1 to the left side, and then we're going to have our local props. So I'm going to go down here and pretend that we're starting at 33, which is our SPI outputs, our direct pixels. And what do we have? We have our arches. I'm just going to literally, with my left mouse button, just drag this over. Now, if you've got a Holiday Coro controller, those cables will literally be named right here. Let me see if we can find a picture of it here. Weirdly enough, there's not a picture, but we label our output cables, and when they come out of the box, they will have a number on them, such as 33, 34, 35, 36 through 38, or 48, for example. And those will literally map up, no funky business, to these numbers. So all you have to do is just drag. I got arches, arch front center 1, drag it to 33, right? It's easy enough. Now, this is where naming your product, your props or your models correctly really makes sense, because you got to know what you're actually hooking up. There's no picture here to show you. You're not dragging it from the picture. So I'm going to go ahead and finish my arches. I'm just going to put them all here just nicely on 33 through 36 right there. And then we also have our we have our singing Christmas tree. And just for fun, I'll put it down here on 41. Remember, our singing Christmas tree was broken into two outputs. In this particular case, the first output's 200 pixels, and the second output is 107 pixels, so there's 307 pixels across it. Notice how xLights knew it was on two outputs, because we said in the model, your two outputs, and it told it what the output counts. You'll also notice off to the left, xLights is keeping a track of how many pixels, right? This will come into more of a play when we start talking about long range, especially if we're chaining things together, daisy chaining. All right, now what else did we have? We had a copycat in there, I think. So copycat, front, left, center, and we'll just put him on 44 right over here. Okay, so now we've got everything set up on the main controller in the center of our display. So if I close this out and I go back over to the layout, if you look at these different props, see over here in the center, and I told you to ignore this the other day, see where it says left, front, center, yard, HinksPix Pro, and it has the channels, how many nodes and all that. It's now mapped those out. So we have these items all mapped out here in the front of the display. All right, back to the visualizer. So now let's work on the simple side of the right side of our driveway. So we're going to use the second jack. Actually, for good measure, we'll just use 13 through 16, since that's on the right side of the receiver. Now, if we have the right driveway, so what we're going to do is we're just going to come over here and we're going to take my right driveway and we're just going to drag it over here. Now, it may not be obvious, but we have made it assumes that we have a direct SPI connection. It's not obvious here in the sense that it doesn't tell you, hey, this is directly connected. I mean, I guess it does because it's highlighted there. But what I'm going to do is say, hey, you're on a long range receiver. And remember, we have an 8 output receiver. So I'm going to right click this and I'm going to say right smart remote. And I'm going to say you're number 0. Now, when you get a 2 output receiver, the first one's going to be 0. And then the second one's going to be number 1. So I right click it and said 0. And if we need to, normally it's defaulted, but it says HinksPix 4 because we're going to use a dual 4 output long range receiver. And you notice here, it put a 0. The 0 is the number of the receiver. That's that dip switch thing that occurs on the receiver. So if you, it might be hard to see, right here, that little dip switch is the position. So if the switch is up in the furthest number position, great, you got number 1. Number 0 is all down. So this is the first receiver, and we say 0. All right. Now, remember, this yellow thing is the jack 4, and it's just data coming out. It's telling me got 99 pixels. Seems right. And we're going to go ahead and map out our other candy cane driveway. So candy cane, right driveway, whatever, 2, and right driveway 3, and right driveway 4. And oops, we're going to then drag this back into the box. You got to stay in the receiver. So we got 6 of them, though. Well, what did he do? We got 2 more over here. So I'm going to start dragging this one out to the 13. Now, right now, it has daisy chained these 2 together. They're not daisy chained. Remember, I decided I was going to put 1 per output. So I'm going to right-click that and say, hey, you're not on receiver 0. You're on receiver 1. And guess what? Now it has 1. So if we had this and we had a switch, the data is going into the first receiver, going out, and then on to the next receiver. So this is output 1, 2, 3, 4. This is the literal output that will be labeled on a cable. This is 1, 2, 3, 4. Okay, and if we hover this, I don't know if you notice in the very bottom right, it says, I got to beef with some of the terminology in xLights, but HinksPix 4 port, long range port, I don't know why it has 2 ports, 2. That is the cable coming out of the receiver, number 2. Okay, we still have 1 more right candy cane drive. We're going to drag it and put it into this one. So now we've got all of those mapped out to the jack number 4, which is the far right jack, and we're good to go. Remember, we're only going to do 1 on the right side, no daisy chaining in that receiver. So we're going to come back up here and use our left jack. So what I'm going to do is I'm going to start with the left driveway. So I'm just going to put my candy canes out here, right there. And it's the same deal as before, right? So I'm going to go ahead, put them in here, smart remote, 0. And I'm just going to put them into the remotes. All right, remember I had to buy a 8 output receiver for the left side of the driveway. So I still got to put another receiver, right click, smart remote. Nope, you're on 1. I get it. Everything starts at 0. I know we don't think it was 0 as a number, but it is in fact where it starts. Okay, and let's see. Shouldn't I have another candy cane somewhere? Did I do too many candy canes? 1, 2, right. left. Oh, did I have 5? So let me go back. Yeah, I'm missing something here, right? So let's go back here. 1, 2, 3, 4, 5. Oh, see, I have 5 over here on the left and not on the right. I probably would not design it that way. Usually anytime you have symmetrical props, like arches and stuff, usually keep them symmetrical looks best. Okay, so I actually only have 5. All right, now we're going to drop our cat onto the 4th output of receiver number 2. Okay, now look over to the left. Notice how it has the pixel count, 294. This is because this pair of wires coming out of this jack feeds output 4 on the first receiver and output 4 on the second receiver. The data is going to the left to the right. Okay, now we have another receiver up on the top of the house. So I'm going to go up here. Now remember, we've got some things daisy chained together. So I'm going to go front, second floor, left gutter, and I'm going to put that up here. And no, it's not on receiver 2. It's now on receiver 3. Oh, I'm sorry. 2. There we go. Now, see these empty boxes? Those are ports that we're not using. So that was a dedicated output. And then we have center left. So we're going to put this one in here. But the center right is actually daisy chained off of each other, right? Okay. Second floor gutter left. I think, oh, I know where. Oh, see, this is where proper naming comes in. You got to like, where is this thing? So when we click on these, so here we've got, for example, second floor left gutter. Oh, left gable, right gable, then left peak, right peak. So, all right, so let's go back here. I kind of wish this was like a picture and you could just literally drag them to the virtual receivers. So left gutter, let's see, peak left. We'll just put him on this one right here, and peak right, and gutter 2. All right. So everything is now lined up. These are daisy chained. See how it's added up all these pixels? Now, if you start putting in some props and exceed the pixel output capability of your receiver, or actually controller, that's why I selected in this particular case a HinksPix Pro version 3. It has 1024 pixels per port. So this number right here, 238, could get up to 1024. If this number ever turns red, you have exceeded the capabilities of the controller. This is another reason why it's good to start with your design in xLights. It will tell you if you made a mistake. Also, look down here in the bottom. If you see any errors, it will tell you there's something you've done wrong down here. You need to figure it out. So look for any red up here, any errors down here. Okay, we're set. And again, I totally know we're running behind. Let's see, we don't have too many questions, so maybe not a problem. Okay, so we have now mapped everything out. So if we look at this, notice how it's got all these names. Now, xLights oscillates between numbers and letters. And this is because within a receiver, like on a 16, let me show you a 16, an example of that. Okay, let's see if we can turn off sharing here. Okay, so this board right here, we gave in receiver A, receiver B, receiver C, receiver D. What you're looking at is not a 16 output receiver. You're looking at a 4 output times 4 receiver. This starts the number over on this side, on the left, and that's receiver. Let's say if we started off with default, this is receiver 0, 1, 2, 3. So just like if you had a 2 output receiver, it would be the same thing. That's why you're going to see where it says smart remote in xLights, it's referring to that receiver. Now, it also refers to that ABC, assuming it's kind of in a block of receivers in a connection. So again, got some beefs with the way that works, but you know, all things considered, still amazing program. Okay, so I'm gonna go back here. So this is again what I'm referring to right here, where it says smart remote C. And we can see what it maps to and all that. Now, you also notice it has a universe channel and all that. You don't have to even concern yourself with that. xLights is just magic. It's just done all that. So if you're used to like light-o-rama, you got to go into it. You got to set the universe. You got to do this, channels, and make sure your channels aren't lapping over each other. xLights has done all that for you. It's all like magic in the background you don't concern yourself with. And it's doing that. Now, it's all there if you need it and you're trying to troubleshoot, and we will definitely be talking about that in the next session we're doing troubleshooting. But you can see that all of these things have been mapped. Anytime you don't see a smart remote, you'll see that has a number, and that's 44. That's the actual SPI output number 44. So literally, copycat front center is coming out of output 44. Okay. So again, let me know if you have any additional questions. One of the questions is, how do you know if you have a HinksPix Pro version 1, 2, 3? They actually all have separate numbers, and you can see them here on this particular product listing. A HinksPix Pro actually has 80 ports on it. We do have a controller with 80 ports, and we custom build them for certain commercial customers. So we actually have 16 times 5 here. This is the HinksPix Pro version 3. What's unique about this, you'll see that it has 2 entire chips just for processing the pixels as compared to the version 2. And the version 1 and the version 2 are almost identical functionality-wise. It's just during the chip shortage, we redesigned our HinksPix run away from a chip that was in short supply over to the version 2 to a slightly better chip, but had similar specifications. The version 3 is a completely new controller in the sense that it is designed for very high pixel counts, 80,000 pixels, high frame rates, lots of pixels. So version 3, version 2, and that's why in the xLights it says V1/V2. Okay. Okay, somebody says brain freeze, may need to start my layout now. All right, so I get it. It's complicated. Of course, if you ever have any questions, let us know. So let's go ahead and get that off there. Now, we do have resources. As I mentioned, we are 2/3 of the way of updating this. We have not updated the HinksPix, but we're almost done with the videos. It takes a long time to make all these videos specific to each individual function, but feel free to go to holidaycore.com/AlphaPix. And what you'll see is that you can select, let's just go there. When you go there, you just select the thing that you're trying to configure. So pick the picture of the thing that you have. So if you have like a 16 long range version 2, just click that. And that's going to only show you the videos that are specific to your controller or receiver. So if you have a long range 4, here it's only going to show you that. Our old one had everything listed and you had to kind of know to go through which ones applied to you. These also generally are also the videos, that is, on the product pages where you purchase the product, and so they'll be specific to that. So that has like how do you set the settings, dip switches, resets, navigating the button interfaces, all that jazz. So definitely feel free to look at any of these, and I really will get this HinksPix finally updated. Okay, so next session coming up here. Oh, actually here, while we're waiting, I'm going to throw up a poll here real quick. Let's see. I'm just curious. What if you've picked a controller or you're going to pick a controller, what is the single most important factor when selecting a controller? Just one thing. Like, what's the thing that steps out in your mind? Like, is it cost? Is it like how much pixels it supports? What matters to you? So while you're filling that out, I'm going to go ahead and continue on. So session 6 is troubleshooting. I cannot express enough how much time we spend explaining to customers how to troubleshoot. And it's not obvious all the time. And there's an amazing number of troubleshooting processes that exist not only in the hardware itself. So in there's usually a test button on a lot of these receivers. There's test buttons on the controllers. There's tests within xLights. There's tests within xLights. And then there's also just testing at the light and prop level. Just today, 2 support tickets on just A/B testing, which is a process where we take the thing that works and swap it with a thing that does not work. And we try to figure out where's the problem. So if you've ever fixed a car, like a car battery, or you're like your computer cable isn't working, you take the cable that works from your wife's computer or husband's computer, you put it on your computer. Does the cable work? Great. Well, then it's something else. It's like your iPhone or the headphones or whatever it is, right? So there's a process to that A/B troubleshooting, and that's super, super critical to troubleshooting. I see so many frustrated customers going, it just doesn't work. I don't understand why it doesn't work. And like it's magic. And it's honestly not magic. It's just a logical set of troubleshooting steps. And so in session 6, we will cover that. And we'll cover everything right down to troubleshooting individual pixels, troubleshooting a string, up to the controller, up into the controller receiver, up into the xLights itself. And then we'll get into the actual troubleshooting of props and models. Maybe even dig up a prop or something. Okay, I'm going to go ahead and publish these results here. It says here, expandability and flexibility, such as like long range and those types of things, are important. And you would be correct. That is a very critical thing and a key part of our flex system, because we do let me show you this. I'm not trying to sell you too much stuff here, folks, but the flex system is based on these ribbon cables, and while many other controllers do have the ribbon cable, the way that they stack together on top of each other, so that when you have a CPU, this is an AlphaPix Evolution, we can then simply just stack the board underneath it. And so most of our controllers use vertical real estate, as where a lot of controllers like Falcon, they use horizontal real estate. And so they have much larger ribbon cables because they have to daisy chain multiple ones. And this allows you to easily stack. So we have up to 4 of these, let's say, long ranges in a single board in a box. And in fact, we even have, again, with the HinksPix Pro version 3, we have 5 expansion boards. So that's 6 boards total. Okay, I'm going to just throw one last poll out there. We love talking about, once y'all do these polls, seeing what the results are. This is a little self-serving. We're curious as to what's the primary reason why you select a vendor. So if you've got your poll results up, you'll have to close that and a new poll will show up. Is it like why are you picking those vendors? Like, why does it matter? What's important? Okay, and in session 7, we'll create sequences. I was very surprised tonight to hear that the #1 cause of concern from a lot of people is sequences. And I get it. I don't deal a lot with that because our job is usually to get you to the point where your stuff blinks and blinks correctly. And we really don't deal with sequences. That's actually a whole nother set of the industry. Lots of sequence vendors. But it is, of course, the critical part of making your show work. It looks good or it doesn't look good. Anybody who's looked at Tom Bettidge's sequences realizes that, right? Because he's like genius programmer. And even the sequences that we resell, they're done by people who are really good at this. They just have a feeling for that. So we'll talk about how we use and create those sequences, how you can tweak them, how you can take imported sequences and then add some extra, spice on the top. So, it's like cooking dinner, beef, and then you throw some extra spice on top. We'll talk about how you can do that. And then in session 8, we will also talk about how to just package that whole thing up. You got your sequence, it's all tested, it's all smoking good. How do you actually get that show to play? How do you get on the SD card? How do you deal with the audio? How do you deal with the FM? What problems you're going to have, especially if you're new and you don't even know you're going to have with like people coming and knocking on your door, that kind of stuff. So we'll talk about that in session 8. So let's go ahead and look at the results here. It says here, wow, that's really interesting. Reputation, prior experience. We do understand that a lot of customers probably, once you buy a controller, it's kind of like underwear or deodorant. You buy the same thing forever because as long as it keeps working, you buy the car from GM, and as long as they don't mess it up and do wrong things or treat you wrong or have warranty problems, you keep on buying those products, right? And so I know here that's a very big concern of ours, and we try to make sure we treat everybody right. Customer support service, obviously your ability to call people. We pick up the phone here, just FYI. You can always reach out to us. We have a very extensive ticketing system. We have almost 200,000 tickets in our ticketing system, and we get several hundred a day typically this time of year, and we try our best to get that count usually to within 5 or 10 tickets by the end of the day to make sure that everybody's getting their responses. So if you've ever dealt with us, we respond very quickly. It's not 3 days later that we'll respond. That would be weird for us. And of course, quality reliability, looks like these are all like 27, 27, 27. That's surprising. Quality reliability, light-o-rama, for example, still fixes their controllers after 25 years. We still get hardware back. And I know you think this is crazy, but like we get controllers back that are 15 years old, like that were from the very beginning. They've definitely, been out there. They get lightning damage, they get squirrels eating them, they get water damage. So your vendor should be able to repair those controllers for you. At a bare minimum, they need to be able to sell you those parts for old controllers. So we still to this day sell all our spare parts for everything except for one controller, which was a resold controller that we sold at the very, very beginning. And that company agreed to take over all support for spare parts and stuff. So we still, if you've got a display that's broken or you got a button board, or you got an output chip or something like that, the vast majority we can do. We also sell refurbished parts. So we almost always give a deal to customers on refurbished items. So it's usually half or more off of that. So reliability, replacements, and stuff like that. And I will give you website content varies a lot between all the vendors. Some of them are fabulous, and some of them have just copied and pasted stuff from their Chinese vendors, and they clearly don't make any effort. So it probably has a very good indication. If your vendor's got enough information on the website, it's got details, they probably actually know their product better. And we know our competitors that are really detailed, and that just really almost always extends into the way they're going to treat you and the product quality and the support down the line. So just like the house that never mows its lawn, you probably can guess like what's inside the house too. It's that same kind of thing. Okay, this has all been really interesting. Thank you for answering the polls. And let's see if we have any final questions. Let's see. We do actually have a few questions. I will go ahead and finish these up. I know we're running a little bit late, but feel free to stay. Let's see. I'm using a Hinks 16 for the first time to control 16 props in a yard. I know it's 4 boards in one. So now I will say the Hinks, when we think of the HinksPix, we think of it as a controller because it's a main CPU. I think what you're referring to is a 4-board receiver. This is by Jason. I know it's 4 boards in one. When wiring it up, do I just go 1 to 16 or does it go not 1, 5, 9, 13 or so on? We'll probably actually follow up with you because that's a long range receiver question. Now, the whole 1, 5, 9, 13 indicates everything that this is a long range receiver. And we do have 2 long range Smart 16s. We have a version 1 and we have a version 2. And they do operate differently. And as I mentioned, you can go in there and you can see the videos that are specific to each one of those. So I would go to the holidaycore.com/long range, click on the board that looks like your board, and then do that. But we'll try to follow up with you tomorrow. I used the 4-year-old video and did set up the HinksPix Pro IP page, the IP address. Didn't use the visualization option. Could that be the reason why the SD export master mode didn't work? So you're right. This is from Karen. Our old videos are old, and that's absolutely why we're updating them. So I'm sorry you had to see that video. Those are still valid on the IP addressing, so those still allow you to change the addressing. We're just adding more of information on those. As to the specific question, in the past, we used to tell people to use the design tool through the web interface, and that is perfectly valid. In fact, we still support customers who have been using that since the start because we started the controllers before the xLights supported the visualizer, and so the visualizers come after that. So our videos weren't updated until just recently for the long range, for example. So could you have set it up with the visualizer? Yes. Would I recommend you do it? If you don't have everything working now, yes, I would recommend using the visualizer. If you still have everything working and it's all good and you're old, you got a HinksPix from 3 years ago and you've used the design tool and xLights, leave it like that. Then next year switch over. So that, I don't recommend people changing a lot at the last minute. That sometimes can cause problems. So could that be the reason why the SD export master mode didn't work? No. If you are using the long range the visualizer for setup, or if you're using the manual setup, it doesn't matter. Master mode will work on both. There should be no reason. I will say that as I think I mentioned a very earlier session, xLights has made some vast improvements that we had done thanks to Scott Hansen and Joe Hinkle. They rewrote some xLights code, and now on the version October 2025, there is an upload option that you can upload to the HinksPix, and we'll talk about that again in session 8. That is much more sophisticated and allows you to do that. And we'll talk about master, slave, secondary controllers, and all that. So we will definitely get around to that. Got some of your older classic controllers. Does it make sense to convert over considering I have 100 hours of sequencing? No. We talk to customers all the time and they're saying, hey, I want to replace my 10-year-old controller. If your 10-year-old controller is working, it's blinking, it's not broken, laying in the water, anything like that, don't replace it. If it does something and works for you, just like when I said, if you're using AC lights and they work for you and you have a controller and it's all working, great, just keep on using it. Don't spend more money on something. Now, if you want to switch it out, great. But the classics are perfectly fine. They still work fine. They have some disadvantages because they are not expandable and they don't have the networking Ethernet. So, is it better to run a show from a computer or an SD card? Early on, the computer was the only way. Starting with light-o-rama, that was pretty much the only way. They came out with what was called the director, and now there's the Falcon Pi player, and the HinksPix Pro has a playback built into the computer, into the controller, and that's all because the chips have gotten cheaper and the cost has gone down over time. So the answer is if it works for you now. I just talked to a customer today. He said, hey, I'm using AlphaPix, which doesn't support SD card playback. I said, are you okay with that? Because we could upgrade you to a HinksPix Pro. And he said, no, I'm okay with using my computer. I got a dedicated computer, just runs my xLights. For him, perfectly fine. It matters to you if you want to not use your computer, not have the cable going from your computer out to the display. There is actually some pros to running it on a computer because you can directly do testing, that kind of thing. So there's some pros and cons. A lot of commercial stuff we do is SD card only because it's in a mall and they don't want a computer, somebody stealing the computer or messing with it. And so they want it fully self-contained. And given that like the HinksPix Pro just includes that, it's not like something you have to buy extra. It's just there and it's just built right into xLights, as we'll see in session 8. Then great. I would use I would generally say today use an SD card. Your audio, by the way, comes off of the controller when you're replacing it on anything. Can I use a receiver with an older AlphaPix 16? I assume you're referring to a controller that has AlphaPix 16 Classic. If it doesn't have a network in and out, like a Ethernet switch, no, you cannot use a receiver with that. It only can be used with the AlphaPix Evolution that has the in and out. I'm using a Hinks 16 for the first time to control. Oh wait, that's the last one. Is either the visualize within xLights or within the IP controller page? Is either the visualize within xLights or within the IP controller page? I'm not fully sure what that means. The visualizer is a button. You have to click in the bottom right corner in xLights on the controller tab. I think that's it. Let's see. Next question. What's better for a beginner, AlphaPix or HinksPix? The answer is it depends. And all of these products exist for a reason. If the HinksPix solved every problem we ever had, we would only sell that. If 12-volt lights solved every problem the world needed, we would have 12-volt lights only. We wouldn't have 5-volt. We wouldn't have 24 volts. So there is a place for every one of these these products. That's why they still exist. In fact, the AlphaPix Classics, which we tell people don't buy them if they are new. But if I have a customer that says, hey, I've got 5 of these AlphaPix Classics. Yeah, I know they're old, but I like them and I know how they work. I've got it figured out. Great. We keep on selling them because they're still a valid solution. Are they the most advanced? No. So does that mean the AlphaPix, which is, if you had to say good, better, best, good is AlphaPix, better is HinksPix Pro version 2, HinksPix Pro version 3 is definitely best. So there's a place in there for each one. I think honestly, and for beginner, HinksPix Pro is got the most future expandability capability, and it has the most options for, like, if you decide, hey, I want to play my show on my SD card. AlphaPix, you can't play you can't play it on an SD card. So that means either a Falcon Pi player, which is really complicated, that's definitely not beginner, or using it from your computer, which is relatively simple. But again, gotta have a computer running. So which one's better? The one that fits your specific needs. And of course, if you ever have any questions, always feel free to reach out to us and we'll be happy to answer them. Okay, well, that's all the questions. And again, thank you so much for attending. And we look forward to seeing you on Tuesday next week for troubleshooting. And I just love troubleshooting. I love customers who know how to troubleshoot because, of course, unfortunately, they're not calling us, I guess. We love to get you educated on how to troubleshoot hardware, and there's a lot of a big capability, as I've mentioned, and I look forward to passing that knowledge along to you for all the years that we've helped troubleshoot with customers. So we look forward to seeing you on Tuesday, and y'all have a great season. Thank you very much.